Okay, so this is section 1.6, day 2, and we're talking about absolute value with inequalities. So, quick refresher about absolute value is that you have two things that you have to keep in mind when you're dealing with absolute value. One is that if you take the absolute value of a positive number, you will get that same positive number out. If you take the absolute value of a negative number, you will get the positive value out. That's measuring the distance from 0. If you take the absolute value of 0, you will get 0, because 0 is 0 units from 0. But what you'll never get when you take an absolute value is a negative value out. So negative numbers go in, they come out, they're opposite, they come out positive. Positive numbers go in, they come out the same. 0 goes in, it comes out the same. And that's how this piecewise function then is developed, because we have 0 or greater numbers, positive or 0 numbers going in to the function, coming out the same, but negative numbers going into the function and coming out their opposite. So they come out as positive. Which means that if I ask you what values of x make the absolute value of x equal to 9, you would have to give me two answers, 9 or negative 9. Both of those values, when you put them in absolute value, come out to be positive 9. But if I ask you what values you put in an absolute value to get negative 4 out, you would say no solution. There's no way to get negative 4 out. And if I asked you what values give you 0, you would only have one. The only way to get an absolute value of 0 is to use 0, because only the number 0 is 0 units from 0. So that's how you want to think about absolute value. But when you combine absolute value with inequalities, like the absolute value of x is greater than 5, well, now we've got to think about what kind of numbers, when you put them in an absolute value, come out greater than 5. You could think about numbers like 6 or 7 or 8, integers, but you could also include 5 1/2, 5 1/3. There are a lot of numbers that have an absolute value greater than 5, and they are all the numbers on the number line here that are greater than 5. But that's not all the possibilities, because if you head to the other side of 0 and you go to the left of negative 5, so you say negative 6, negative 7, negative 8, those are also solutions, because their absolute value will make them the opposite and make them positive. So the way that you would imagine it on the number line is the numbers that are over here and the numbers that are over here. If you put them together with the word or, you have your solution. So absolute value greater than, we're going to use the word or. We're going to say places where x is greater than 5 or where x is less than negative 5. Or as an interval, you could write it as use all the numbers from negative infinity to negative 5, unite that with all the numbers from 5 to infinity. And that's how you would express your answer, one of those three ways, whichever way makes most sense to you. But if you have an absolute value matched with a less than sign, this is where we're going to have an and situation. Because if we think about the numbers whose absolute value is less than or equal to 4, we would have to use numbers like 3 and 2 and 1. But we'd have to be careful that when we got on the other side of 0, we didn't go too far, because if we went beyond negative 4 to negative 5, that won't be a solution anymore, because its absolute value is positive 5. So we're going to have a boundary here and a boundary here at negative 4. And we're going to be using all the numbers in between. That's an and statement. We could write it as numbers that are less than or equal to 4 and at the same time greater than or equal to negative 4. Or as an interval, it's bounded on both sides. We don't use infinity. We say numbers between -4 and 4, including -4 and 4. So that's an and statement. This statement that we're making, the and or the or, is about what's inside the absolute value. So in this case, I would say the solution to this is when 9x is greater than 27, or when 9x is less than -27. Those are my two or statements without showing it on the number line. But the solution has to talk about x. So you want to say the solution would be x values greater than 3 when I divide both sides by 9, or x values less than -3. And that could look like an interval. If you're moving to Math 22, you want to start thinking this way. An interval with a united sign, because you're putting those two together. You have to be very, very careful with absolute value that you isolate it before you start making these statements about it. And number 7 is not isolated because there's a 5 times the absolute value. So we are not going to make our and or our or statement until we divide both sides by 5. Some people are tempted to try to take the 5 into the absolute value. You will never distribute in. You need to take that right out of your head. It's never going to happen. You will never take a number that's outside and distribute it in. You'll always try to get rid of it by dividing it if it's being multiplied, subtracting if it's being added, doing the inverse operation. But now that I know 6 minus 2x has to be less than or equal to 4, now I know that I'm in my and situation, but I need to put the boundaries 4 and -4 on what's in the absolute value, not on x. So that quantity, 6 minus 2x, is bounded by 4 and -4. But now I need to solve for x. We always want to talk in terms of x, not the function that x is living in. So we're going to use our double inequality rules to subtract 6 and say -10 will bound on one side and 2 will bound the other side of -2x. And now I'll divide everything by -2. And now I'm putting x in between the number 1 and the number 5. And there's my solution, all the numbers that live between 1 and 5, including, which could just be written as the interval, like that. So looking at 8, that also has to be isolated. It is not isolated right now. -2 times, nope, I don't want that -2. I need to divide it away. But just like in any other inequality, when I divide by a negative, I need to flip my signs. I need to write it as, now the absolute value has to be less than or equal to 0. Well, we know from the beginning at the top, we can't, that absolute value cannot give back a negative value. It can't be less than 0. Less than 0. It can be equal to 0, but not less than. So the only solution I'm going to get here is the one that makes 2x plus 1 equal to 0. Since I can't make it less, I will make it equal and get one solution, which is the number -1/2. If they had tried me to get to answer what makes it less than 0, I would say no solution, but I can make it equal to. Isolating for number 9 means getting rid of the +6. So I'm going to write isolate here. I forgot to write it here, but it's one of the biggest things people forget. So we want to take our absolute value, and by subtracting 6 from both sides, make a new statement. Our absolute value is greater than or equal to 12. Well, greater than or equal to is an or, so I want to make sure that x plus 6 over 2 is either greater than or equal to 12, or it could be less than or equal to 12. Negative 12, sorry, two changes. Less than or equal to negative 12. And I need to solve each one independent of the other to get my answers. So I'm going to multiply both sides by 2. I'm going to subtract 6 and get my 1 statement. And I'm going to do the same thing over here. Multiply by 2 and subtract 6 to get my other statement. So now I have values from negative infinity all the way up to negative 30, and I'll have to unite that with numbers from 18 all the way out to infinity. So I'm isolating my absolute value, and then I'm making my statement about it, which helps me drop absolute value and solve two different equations. So the last problem we're going to do similarly. It is already isolated, but we want to notice that it's an and. So an and statement, I put what's in the absolute value and bound it on either side by the numbers 1 and negative 1. The value that I put in that absolute value can't be any greater than 1 or any less than negative 1. And once it's bounded like that, I can start solving my double inequality by taking away 1 from all three pieces. And then I can multiply everything by 3. And then I can divide everything by negative 2, remembering that that means flip my inequality. So the answers to this are all the numbers between 0 and 3. So when you're solving these absolute value inequalities, things to remember, you need to isolate your absolute value if it's not isolated. Divide away what needs to be divided, subtract away what needs to be subtracted. If your absolute value is greater than a number, you're going to set up an or statement. That whatever's in here is greater than that number, or whatever's in here is less than the opposite of that number. If your absolute value is a less than, that's when you're going to use an and you're going to place what's in your absolute value between this number and its opposite. The other thing you want to keep in mind is if you're doing an absolute value and you have a negative number over here, or even 0, you've got to think carefully about it, because that might mean there's no solution, less solutions than you thought there was, maybe anything will work. You have to be careful when these numbers are there. You've got to think about what the inequality means, knowing that no negatives come out of absolute value. So those are my little tips. Please try your homework, and we will take a look at it when I get back.